Welcome back to our videos on math. Today we get to solve trig equations. Now, in solving any kind of equation, you have lots of tools or tricks like we saw in the last video at your disposal. For example, in solving this trig equation here, I can use the division principle. So divide both sides by 2. In this one here, I could move this 3 over to the other side like we learned how to do in absolute value equations. And then treat the inside as a plus and a minus. This one here, we can square both sides. So these are typical ways that we've been able to solve equations. All the time, what we're going for in the end is x equals something. In trig equations, we do the same thing. In fact, what we typically do is manipulate our equation down till we get something like sine theta is equal to some number. And then we'll solve for that theta or solve for that x. Doesn't matter what the name of the angle would be. So we do similar things in trig equations that we've done with lots of other equations. Here's a few steps that I've found to be useful in solving trig equations. First, look for any kind of simplifications or identities or any other kind of trick that might be useful. There might be some factoring that you have to do. You might use addition, subtraction principle, that kind of stuff. Then you want to isolate the trig function. So move whatever you have. You might have something here, and then you have a sine function here, plus some other stuff is equal to something. So get rid of all of the things on one side. Get rid of that, get rid of that. So you're left with just sine theta is equal to something. Okay? So use whatever tricks you have at your disposal to get sine theta is equal to something. Then find the solution to that angle. So we can do the arc sine on both sides and we can solve for that angle. The angle that we come up with, it will be known as our reference angle. It won't be our final answer. It might be part of it, but it won't be the whole final answer. It'll be a reference angle from which I can determine the exact answers. And then, from any, given the restrictions that are there, determine the actual or exact angle solutions. Let's try some. We'll start you with some baby ones and work your way up till we have some more complicated ones. Here's one. Cos theta is equal to 1/2. My goal here is to figure out what theta has to be. Now this is a simple trig equation, and I've actually already isolated the trig ratio. The cos theta is there by itself. So all I need to do now is to figure out what angle has a cosine ratio of 1/2. Well, this is one that I recognize from over in one of my special triangles here, that the cosine ratio, it looks like the cosine ratio of 60 degrees is adjacent over hypotenuse, or 1/2. And so the solution to this equation, or I guess a partial, would be that if this angle were 60 degrees, it would give me a ratio of 1/2. Try that on your calculator too. Figure out what the cos of 60 is. Does it give you 1/2 or 0.5? Now this, as I mentioned on the last slide, is known as our reference angle. So it may be part of the final answer, but it may not be. When I say it's a reference angle, what I mean is that a 60-degree angle anywhere on the quadrant will give me a ratio of 1/2. So if I have here a 60 degrees, the cosine ratio with that angle will be equal to 1/2. If I drew an angle over here, again the cosine ratio of a 60-degree angle will be 1/2. Down here in the bottom two quadrants, same thing. So what happens is that for my one answer here, my reference angle, I really have 4 different possible answers. So this one is 60 degrees. This angle here would be 180 minus the reference angle, or 120 degrees. This angle, maybe I'll use a different color. This angle 180 plus 60, or 240 degrees. And this final angle, this one, would be 360 degrees minus 60, or 300 degrees. So these are all the possible answers or solutions to this equation. But some of them may not work. For example, if you type cosine of 120 in your calculator, you get 0.5, but a negative 0.5. That doesn't work with our equation here. So 120 doesn't work. Similarly, if you would have tried 240 in there, it also would have given you a negative 0.5. But if you'd have tried 300 in, you would have found that it does give you a positive 0.5. And the way I like to look at these is I look at cos and x, or cos theta, and x as being similar. Wherever x is positive, cos will be positive. Wherever x is negative, cos will be negative. So x is positive in quadrant 1 and in quadrant 4. Therefore, those two angles formed from the reference angles will be my solutions. So 60 degrees is my reference angle, and indeed it turns out to be part of my solution. So my solution will be 60 degrees and 300 degrees. So if I plug either of those in, I'll get a ratio of 1/2, or 0.5. Let's try another equation. Oh, here's one where it looks like I've got a bit more work to do to isolate my sine theta. Not a whole lot, I just have to divide by 2. So I get sine theta is equal to a negative root 3 over 2. Again, root 3 over 2 I recognize from one of my special angles here. So which ratio or which angle will give me a sine, opposite over hypotenuse, of root 3 over 2? Opposite. That's this one here. So sine, it looks like sine of 60 degrees is root 3 over 2. So here then my angle will be 60 degrees again. They won't all be 60. But this, as we've seen before, is our reference angle. And notice that I sort of disregarded that minus sign. Let's deal with the minus sign now. If I want to indicate the 4 possible places for my angles, there'd be 60 there, another 60 degrees there, always off the x-axis 60, and a final 60. This one, what we found was 60, 120, 240, and this angle was 300 degrees. Now I look back and I say, where is the sine ratio negative? I'm just going to write that. Where is the sine ratio negative? Well, I know sine and y go together, so wherever y is negative, sine's going to be negative. So y is negative in these two quadrants here. Those would be my two solutions. Up here, sine is positive, would not be included in my solutions because I'm looking for a sine ratio that is negative. So my answers then to this question would be theta is equal to 240 degrees and 300 degrees. Notice that the reference angle itself is not in my solution. Now, one thing that I didn't talk about earlier was here, this question gave me a restriction as to what the domain or what values of theta I could use. And it said I had to be restricted in between 0 and 2 pi, or between 0 and 360 degrees, which I am. I'm in between 0 and 360. But in the question, if they indicate that my domain is 0 to 2 pi, typically that says that my answers to the question should be expressed in radians. So at the end of the question, that's what I would typically do, is convert this to radians. I believe this one's 4 pi over 3, and this one is 5 pi over 3. I could do those as we've seen before. I could take 300 degrees and multiply it by pi over 180, do a simplification, it'll come out to the 5 pi over 3. Okay, so there's another example of solving a trig equation. Let's try one or two more. Here's one. I've got 2 cos squared x is equal to 1. I haven't seen a squared yet. but I probably would divide both sides by 2 first. So to give me a half, again to isolate and just get cos x, I'll take the square root of both sides. So I'll get not cos squared, I'll get cos x is equal to the square root of 1 over 2. Also notice this was squared, so I square root this side. This one must be a plus or a minus. I'm going to get more answers because of that plus or minus. Now, in just simplifying this a little bit, I get cos x is equal to the square root of 1 is 1 over root 2, and this is plus or minus. Now I'm looking for a cosine ratio where I get 1 over root 2. Okay, there's no root 2's there. Well, it's got to be a 45. Let's pick this one. 45 degrees, 1 over root 2 is the cosine ratio, 45 degrees. Therefore, I would say that x is equal to 45 degrees. Again, that can happen in 4 places. 1, 2, 3, 4. All 45s off of the x-axis. To name them, this one would be 45. This one would be 180 minus 45, or 135. This one would be 180 plus 45, or 225. And the final angle would be 360 minus 45, or 315 degrees. Now in this question here, it says that the cosine ratio is positive or negative. Therefore, all 4 of those answers will work. 45 degrees, 135, 225, and finally 315 degrees. All 4 of those answers are solutions. Let's check back, see what our domain was. It was in degrees. Phew. Don't have to do any more work. I'm done right at that point there. Let's look at another one. This one looks to be a little bit similar to ones we've had before. Let's move the 1 over. 3 cos x is equal to 1. Divide both sides by 3. I get a third. I don't know. That one doesn't really match up with any of my special angles. If it doesn't match up with a special angle, simply just solve that on your calculator. So it must not be an exact value, so I'll go inverse cos or arc cos of 1/3. And it comes out to about 70.5 degrees. This again is my reference angle, which could happen in 4 places. 1, 2, 3, 4. I'm not exact there. But the cosine ratio is positive, indicating that it could only be in this quadrant and this quadrant, because those are the only quadrants in which x, cosine x, is positive. You can also use that cast rule that we've looked at before. Cosine is positive, all are positive, only sine's positive, only tan's positive. So these are the 2 in which x, or cos, is positive. So 70.5 is my reference angle, and indeed that's part of my answer. And my other answer will be whatever 360 minus 70.5 is. I think it's about 289.5 degrees. Notice in the question it asked us for radians, so I should at this point take both of my degrees and multiply them by pi over 180 and solve for what my radians are. So if I multiply that by 3.14 and divide it by 180, I come up with 1.23. So 70.5 would be 1.23 radians, and I would do the same thing for 289. Okay, let's look at some other equations. Okay, here's a trig equation where I've got, looks like I have 3 terms. This is almost looking like a quadratic, doesn't it? Cos squared, cos, and a number. Let's rewrite it like that and follow that through a bit. Plus 2 cos x, bring this over, it'd be minus 3 is equal to 0. Yeah, that's cos squared, cos, and a number. Very similar to x squared plus something x plus a number is equal to 0. If I have this kind of format, quadratic formula or factoring are all tools or magic that I can use to to solve this equation. Let's factor it. I think this one's factorable. So I'll have a cos x here and a cos x there. Two numbers that multiply to a negative 3 and add to a positive 2. So probably negative 3 times 1, positive 3 times a negative 1. Does that work? Cos squared plus 3x minus x, yep, minus 3. There we go. So here's my two factors. Now I use zero product, so cos x minus 1 is equal to 0, or cos x plus 3 is equal to 0. Move sides, so cos x is equal to 1, or cos x is equal to negative 3. I can do this on my calculator, and I find out that x, in this case, would be equal to 0 degrees, which is a reference angle. In this one, when I try and do this on my calculator, I come up with error or undefined. And so from this root, or from this factor, I'm not going to get any more factors. But let's explore this one, because this is a reference angle. So it could happen, I guess, in 4 places, but 0 degrees is here, along here, or 0 degrees is along here. So I could say that there's 0 degrees, x is 0. I guess I could also say that it's 360 degrees, because that's a coterminal angle. So 0 would work, 360 degrees would work. I wonder about 180, because it's right on the 0 there too. Oh no, but cos is positive. Cos is not positive over on this side, it's negative. So it must only be these ones here, 0 and 360. Try that too. Try and do the cos of 180. You'll find that it is 1, but it's negative 1. So that solves that equation. Just one or two other ones to try. Here's one where, oh, it looks like I have 1, 2, 3, 4 terms in this equation. This one's almost set up. It looks like it's set up for that group factoring, where I factor something out of these two, factor something out of these two, and then do a group factor from that. I won't finish this question, but it's similar to the question that we just did, where I'll get two factors at the end, and I'll solve each one separately. Let's look at one final equation, where I have secant squared minus 2 tan squared is equal to 0. One thing that freaks me out a little bit about this question is that here I've got two different ratios. In all of the other questions that I've done so far, they've all, as you can see, only had one kind of ratio in it. But this one's got two. I need somehow to get that to one ratio. And if you remember what we did in the last unit, we saw an identity that looked like this. 1 plus tan squared would be equal to secant squared. Anytime I see this, I can replace it with that, or vice versa. So I have a secant squared. I'm going to replace it with 1 plus tan squared. So instead of secant squared, my identity says I can replace that with 1 plus tan squared. Minus 2 tan squared x is equal to 0. Notice that now by doing that, I only have one type of trig ratio. And so I should be able to solve this one now. So 1 plus tan, 2 tan squared minus 2 tan squared. This is 1 tan squared minus 2. So this would be 1 minus 1 tan squared x is equal to 0. If I move the tan squared to the other side, I get tan squared x is equal to 1. Now I'll square root both sides, so I'll get plus or minus the square root of 1, which is 1, is equal to tan x. Now I'll solve this equation. If I don't know exactly where it is, I will do it on my calculator, but it turns out that I get an x value of 45 degrees, which is a reference angle, as we've said tons before, and it can happen here, 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 or here. And tan x can be positive or negative, therefore all four of those angles are in. So my angle then would be 45 degrees will work, or 135 degrees, or 225, or 315 degrees, which I could convert to radians if they asked me to. Didn't state in here, I'm leaving them as my degrees. So we've talked then quickly today about trig equations, and saw that to solve them we needed to apply whatever kinds of trickery we needed to in order to get the trig ratio isolated. Once it was isolated, I could find a reference angle. From the reference angle, I could plot all four on my quadrant and then select whichever ones meshed or worked with whether the ratio was positive or negative.